Solar sails, also called photon or light sails, are propulsion systems which are using radiation pressure exerted by sunlight on large mirrors. This is an proven effect which works on all spacecrafts in orbit. It functions much like a sailing boat, with the difference that it uses solar particles instead of air. There's another possibility to benefit from this effect. This is producing a large laser beam and so generating more potential energy than through solar light. But why should you use a solar sail instead of a common chemical propulsion system? The solar sail has two clear advantages. There are no moving parts and no fuel is required. That means that the reliability, lifetime and reusability is on a very high level. The solar sail could potentially be used as an interplanetary shuttle for cargo and human space travel. Here are some examples for you so you get a sense of the scale and the thrust of the solar sail. A 800 by 800 meter solar sail with a mass of 5 grams per square meter could deliver in 400 days a cargo of 2000 kilograms to Mars. If you have better materials with 3 grams per square meter and a 2000 by 2000 meter sail, it would be 23 tons on the same mission. The attitude control of the spacecraft can be achieved by controllable wings, movement of individual sail, and through movement of a control mass to shift the center of gravity. Another possibility would be a reaction wheel on the vehicle. The highest thrust to Mars design is a square sail. This configuration has 4 masts on the dark side of the sail, spread out and pointed at the corners. There's a big problem in designing solar sails. The sail can only be used if the temperature is kept within the material limits. In this arrangement, the sail is protecting the support structure, which can't get too hot, and thus solves the problem. Another arrangement is the helio design. Here the sails are pointed in 4 different directions, which you can see in the sketch. Then the spacecraft is set in angular motion. Through this, the structure is held out by the centrifugal forces and gets stiffer. Another advantage is here the simpler deploy process. The sail is just compacted on a spool and rolled out while the spacecraft spins. Also, the attitude control mechanism is simple. The angle of the blades will be changed, similar to the cyclic and collective pitch of a helicopter. The third arrangement is a ring sail. It also rotates for stability, and if it is fast enough, it could potentially produce artificial gravity. The most commonly used material design for a solar sail is a thin layer of aluminium coating with a plastic sheet on the backside of it. The plastic sheet provides mechanical support and flexibility. The metal layer is needed for reflectivity, because a reflective surface has most efficiency by dealing with solar pressure. By 100% reflectance, there would be a force of 9 micronewtons exerted. With the aluminium layer, you can get up to 88 to 90% reflectivity. In the helio design, the mechanical support through the plastic layer is exchanged with rotating. The problem is even though that there is no flexibility in the metal, so folding for launch is a real challenge. So now we have a good understanding about how a solar sail propulsion system functions. Now let's get into a real example of a working solar sail. I think it is the most popular project in this field, the Lightsail 2 by the Planetary Society. Unfortunately, not by the Space Society. The 4.5 by 4.5 by 19.2 inch CubeSat, which weighed 5 kilograms, was launched on the Falcon Heavy in 2019. $7 million was the cost of the project. The CubeSat first unfolds its solar arrays and then unrolls 4 tape measure Lightsail booms, which pull the spacecraft's 4 triangular sails from storage. When rolled out, The sail is 5.6 by 5.6 meters big. The sail thickness is 4.5 microns. This is less than the width of a human hair. The acceleration of 0.058 millimeters per second is enough to raise the spacecraft's orbit by several hundred meters per day. I think this project is a step in the right direction. I hope that more and more startups try something like this in the future. Anyways, thanks for watching. If you liked the video, give it a thumbs up and please consider to subscribe. Also, if you have any feedback or ideas for future videos, let me know down in the comments.